Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 5, exponent, polynomials, and polynomial functions. In this particular video, we're going to take a look on section 5.5, the greatest common factor and factoring by grouping. If by any chance you missed 5.1 through 5.4, exponent and scientific notation, polynomials and polynomial functions, multiplication of polynomials, I strongly advise you to go back and watch the previous video. This video, our focus is on the greatest common factor and factoring by grouping. So, one thing you need to remember about this section, about this chapter in general, factoring is a very important topics in algebra. It's the fundamentals of all other topics that we would cover in the future. So what we're gonna do in these sections, we're going to identify the greatest common factor that we call the GCF. We're going to factor out the greatest common factor, the GCF of a polynomial's terms. We're going to factor polynomials by grouping. So greatest common factor, largest quantity that is a factor of all the integers or polynomials involved. How to find that, because factoring is the reverse process of multiplication. It is the process of writing a polynomial as a product. So what we do here, uh, we need to learn how to find the GCF of a list of monomials. To factor a polynomial, we first need to factor out the greatest common factor of the product of the GCF, of its terms, sorry, using the distributive property. So the GCF of a list of terms or monomials is the product of the GCF of the numerical coefficients and each GCF of the powers of common factors. So the first thing to do, we need to find the GCF of the numerical coefficients. That means what's the common factor for each term, and we need also to find the GCF of, the GCF of the variable factors, the product of the factors found in step 1 and 2 is the GCF of the monomial. So I know what we said looks like a lot of works, but don't worry about it. So and if there are no common factors or it's prime, so the common factor would be 1. So it's prime. By instance, if they ask you find the GCF of each list of numbers. So let's say if you have 12, suppose you had 12x and 8y if it was with a variable. So look at the numbers. What is the common factor? So the way you need to find the common factors, of course, these two numbers, you can do 3 times 4 give you 12, 2 times 4 give you 8. So 8 would be the common factor. But this is how you need to do it. First of all, you need to write the prime factorization of 12. All the factors you use to multiply to obtain 12 must be prime. For example, we know 4 times 3 is 12, or we can say 2 times 2 times 3 is 12. And you do the same with 8. So 8 is only 2 times 2 times 2. So to find the GCF here, for this GCF, the greatest common factor, you take only the repeated factors. For example, you see both of them has 2. So we take 2. Both of them has 2 again. No, times 2. But 12 has 3. 8 doesn't have 3. You cannot take 3. And the last 2, only 8 has it. So the greatest common factor here is 4. Not all the As I said, if you take 7, what are the factors for 7? Because 7 is prime, it's only 1 times 7. But for 20, 20 is 5 times 4 or 4 times 5, but 4 times 5, if you want to rewrite 5, 4 is 2 times 2. So the prime factorization for 20 would be 2 times 2 times 5. Now, looking at the factors for 7 and 20, you realize there is no common factor. The first one has 1. You know the GCF here would be only 1 because I could put 1. 1 doesn't change anything. Even though I said 1 times 2 times 2 times 5, it will still be 20. So the GCF would be 1. That we don't commonly write. We just say there is no GCF, right? There are no common prime factors, so the GCF is only 1. All right. Now, this is when we use letters. For example, suppose we have 4x plus 10, like this. If they ask us to factor, you know 4 is 2 times 2, x, and you know 10 is 2 times 5. Because you have these two 2's, so what you can do, you can factor out the 2, so you have only 2x left for the first term and 5 left for the second term. That's why we need to identify the greatest common factor. It will help us to factor out the common factors. Now, 12 and 8, 7 and 20 are real numbers. What if we need to do it for variables? Now, if you see x cubed is x times x times x, but x power 7 is a factor of x 7 times x, 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 and x. Now, the GCF would be only the repeated factors. Remember, you see these two, so I'm going to have x, another 2, x, another 2, x. Now, we have no more x in x cubed, so common factors here is x cubed. What I mean by that, suppose I have 2x cubed plus 5x power 7. Now, if I want to factor out the common factor, we know x cubed, you have 2x cubed plus 5 times x cubed times x power 7. Remember, we do when you have same base, sorry, with the same base, what we do, we add the exponent. When you have factors with same base, we add the exponent, and we talked about it before, okay? So you can factor out x cubed. What you have left is 2 plus 5x, oh, that's what's supposed to be 4, sorry, power 4. All right. Now, this is just a parenthesis of what we can do with it. But look at this one. When you have 6x to the 5th power, what I can do 2 times 3 times x times x times x times x times x, 5x, 4x cubed. We're going to have 2 times 2 x times x times x. So what is the GCF? If you pay attention to what we just did, the GCF would be what? Yes, we have the 2 and we have x 3 times. So the GCF would be 2x cubed, right? Yay, that's a good example. So as we move forward, we're gonna continue to have some examples like this. But looking at the GCF, how to find the GCF of those listed terms, as you can see, for a cube b square, if you do a times a times a, b times b, if you do a2 b5, you can do a times a, b 5 times, right? And if you do a 4, b 7, so we have a 4 times and b 7 times. All right. Now, if you're looking for the GCF, all you need to do because I see a, so I'm gonna do a. I see another a, I go with the shortest one, a, a, so that's times a. Now, if you look at this on the second, for the second term, there is no more a. So I can, even though the first term has a cubed b squared, the last one a fourth, B7. I cannot continue to take A because we need to take it with respect of the second term because it has the lowest exponent. Now, we can say for certain we're going to have only B squared because if we look at this one, because we're going to have only B squared. So that's what we're planning on having, the B squared, because B squared is the only one with B times B, because you see you have B, B, and B, and you have another B, B, and B. So there is no more B's for this first term, so we're gonna stop here. So the GCF is A squared B squared. I do it step by step here to help you just have an idea on how that's supposed to work, okay? But let's suppose that we're not gonna do all of this after. Remember that the GCF of a list of terms contain the smallest exponent on each common variable. Smallest components, like look at that, smallest exponent on x because you have x power 6, x power 3, so we take the smallest one, and the smallest exponent on y because we have y power 4 and y power 5, so we know the GCF would be x power 3, y power 4 for only the two of them. The first step in factoring a polynomial is to find the GCF for all its terms. Okay, the first term in doing the trinomials is to find the GCF. The GCF, so we're gonna do that, okay? Then we need to write the polynomials, okay, as a product or by factoring out the GCF from all the terms, okay? So the remaining factors in each term will form a polynomial. So that's what we're planning on doing. Okay. All right. Sorry for the noise. So here they ask you to factor. You need to understand, what's the common factor between here and here. Okay, so 9 is 3 times 3, right? 3 times 3x plus 3 times 1. So the common factor here is 3, so we have 3x plus 1 left. Do not say 0. That's why I said 3 times 1 for the second term. We don't only have 3. We know 3 is a product of two factors, 3 and 1. So that's why I put 1. Now, if they said factor out the GCF in each of the following, first of all, we need to find the common factors, 6, 9, and 12. What is the common factor between 6, 9, and 12? We know 6 and 12, the common factor is 6. But 6 and 9, the common factor is only 3. And 9 and 12, the common factor is only 3. So we know we can rewrite this one as 3 times 2x times x squared. Because I said only x because this one has the lowest exponent, which is 1. Now, minus 3 times x, 3 times 3 times x, that's x squared. 3 times 4x. Now, if you factor the 3, like you get rid of that 3, you get rid of that 3, you get rid of that 3, and you can also add 1x of it. So you get rid of that x, this one, and this one. So see what you have left. You have 2x squared left minus 3x plus 4. Okay? And there is no common factor between 2x squared, 3x, and 4. So we're going to leave it as is. Now, when I look at this one, look, 14, 7, 7. So we know 7 would be the common factor. So if we get rid of 7, then we have 2 left here. X is another common factor. So if I get rid of x, 1x is going to be power 2. 1x, we're going to have only x. This x is gone. Now, let's say we have, x power 2, right? Y, all of them has Y, so we're gonna say 7xy. For the first term, we have 2x squared left plus only x left. And the last one would be -1. Remember, there is always a 7 times 1 here that you don't see. Okay, we never write exponent for you know x power 1. We don't say power 1. Like if we have 4, we don't say 4 times 1. We know 4 times 1 is 4. So, but if they ask you to write 4, I mean 5 with as a product of two factors, you can do 5 times 1 would be equal to 5. Okay, again here, huh? Let's suppose if you let x plus 2 equal a, and that's an example, right? So it's like you have 6a minus y a. If I let x plus 2 equal a, I just substitute x plus 2 for a. Now, do you see you can factor the a? So if I factor a, I have 6 minus y left. So what it was a again? Yes, a is x plus 2. You can factor and make it much easier for you to factor out the common factor. Here, the common factor is really x plus 2. Again, here, down here, you see, it's like for me, if I let y plus 1 be b, for example, that's an example, right? I could write something. So I have xy b minus b, right? Now let's factor b. We're gonna have b times xy minus, remember b times 1. There is always a 1, like this. And what is b again? Yes, b is y plus 1 times x, y minus 1. So I think that's something we do. Anyway, our goal here was really to, factor out the greatest common factor of a polynomial's terms. I think we succeed with that, right? Now, our next goal is really to factor polynomials by grouping. Grouping is very important in algebra, in mathematics in general, and usually you do grouping when you have about four terms. So group the terms in two groups so that each group has a common factor. That's the first step to go. You factor out the GCF from each group. If there is a common binomial factor, and factor it out. If not, rearrange the terms and try these steps again. Okay? So that's one of the things we need to do. Now, let's say that we have these terms, x, y. Now, we remember the first goal is to group the terms in two groups so that each group has a common factor. I see y. Y, I can say x, y minus 5y. So for me, there is two terms in this one. There is a plus, and I said 3. 15 common factor is 3. So I can do 3x minus 15. That's the first step. The second step, we need to factor out the greatest common factor from each group. What is the common factor in the first group? Y. So if we pull out y, we have x minus 5 left. Plus, common factor is 3 because 5 times 3 is 15. So if we pull out 3, we only have x left in this one, minus 5 because 3 times 5 is 15. So we can go very slowly with that. And surprisingly now, remember when I said let x minus 5 equal a, I just put a number. But once you understand it, we can just figure it out. So ya plus 3a, that gives us a factor y plus 3. What is a? X minus 5 times y plus 3 would be the answer. Okay, I'm hoping that x minus 5, y plus 3 is the common one. Now, when you group, doesn't mean you're gonna have xy. Sometimes they are all in x with different exponent. But the good thing is that there is x, there is x. If I want, I can factor out, I can group these two first. Remember, the goal is to group the terms in two groups so that each group has a common factor. So 15 and 10 has a common factor. X cubed and x squared has a common factor. Now, 6 and 4 has a common factor too. So 10, 15 and 10, what's the common factor, please? Yes, 5. X squared, x cubed has a common factor. What's the common factor, please? X squared. Now, what we have, 5 times what give you 15? 3, there is one x left. And 5 times what give you 10? 2. Now, the second one, what is the common factor between 6 and 4? Yay, 2. Then we have 3x minus 2. As you can see here, 3x minus 2, 3x minus 2, 3x minus 2 is the common factor now, and we have left 5x squared from the first one plus 2 from the second one. So this is factors. When we say factoring, between the parentheses, there is no plus, no subtraction, no divisions. It's only multiplication because when you have parentheses time parentheses, you know it's multiplication. All right. Now let's try some of the examples here. Also doing by grouping. You for the record, you can group any two. If I decide to group this one and this one, as long as they have a common factor, I can put 2a squared plus 2a because I see they have common factor 2 and a. And also here I see 5, 5, b, so I can put these two together as well. Doesn't mean I only always to take the first two and the second two. So if I do that, 2a is the common factor. I have a plus 1 left. Okay. Now, 5b is the common factor. I have a plus 1 left. Now, a plus 1, you can factor a plus 1. Then you have 2a plus 5b there. 5b. Okay. So this is the answer right there. Now, if we go with another examples, because as I said, we can have as many examples as possible. Um, One of them would be I can factor any two. If I factor the first two, it's fine. But if I factor, I mean, I like these two. Okay, I can put combine x cubed and x squared, and I can combine 4x plus 4. There is no multiplication sign in the middle of these two parentheses. So what I need to do is factor x squared, so I have only x plus 1 left. Factor 4, I have x plus 1 left. When I factor out with the GCF from each parenthesis, what I have left in the parentheses must look like the same, must be the same, because at the end, I would factor x plus 1. That is the common factor, and I have x squared plus 4 left, and that's the best we can do. Remember, if it was x squared minus 4, it would be like x squared minus 2 squared. And you know we covered this one already, x squared. Oh, no, 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 no. Never mind, because we haven't done this one yet. All right. Next example would be, oh, that would be the last one in this section. So what we would do again, we can, if you look at these two, if I try to take these two, there is nothing in common between these two. Okay? We don't have any common terms between these two. So I cannot take this. So I need to find two terms that has common factors. What I realize, this one and this one has something in common, and these two has something in common. So what I'm gonna do, 3xy minus 3x plus 2 minus 2y. You see? Because 3xy, I can factor 3x. I have y minus 1. Okay. And I can factor 2. I have 1 minus y. Oh, look at that. We cannot factor this one like it is because y minus 1 and 1 minus y is two different things. So what we can do, if you want, you can rewrite it 3x y minus 1 plus 2 negative y plus 1. And this one right here, if you want, you can factor the negative. So you have y minus 1 as a factor. So that would give you negative 2. If I bring the negative outside with the positive we have here, 3x times y minus 1. Okay? We realize, okay, we realize we have y minus 1 here. So this one now become negative y minus 1 times 3x minus 2. It's amazing on how we can factor out the GCF. And then by grouping, I would like you to review and pause the video at any time because there are so many other exercises we would do in the future that would require you convert any trinomials you have into a four term so you can factor by grouping. Hope this video will help you to understand better the greatest common factor and factoring by grouping. In a different video, we would come back for factoring trinomials. Take care.